Active Directory works because a few core services cooperate continuously. Users prove who they are, permissions determine what they can access, DNS helps systems find the domain, and group policy keeps configuration consistent at scale. We've already covered the AD building blocks: domains, forests, domain controllers, users, groups, computers, and OUs. Now we move from structure to operation: how sign-ins are verified, access is granted, services are found, and policies are enforced. This is essential context before planning any move toward Microsoft Entra ID. Think of Active Directory as a set of cooperating services, not just a database of users and computers. Authentication answers, "Are you really this identity?" Authorization follows with, "What is that identity allowed to do?" DNS helps clients locate domain controllers and related services. Group policy turns the directory into a management platform by applying security settings, desktop rules, scripts, and preferences. When one of these services is misconfigured, the whole domain can feel unreliable, even if the directory data itself is correct. Authentication and authorization work together, but they solve different problems. Authentication proves that a user or service is who it claims to be. In Active Directory, that may involve a password logon, a Kerberos ticket, or NTLM challenge response. Authorization happens after the identity is known. AD checks what that identity can access through security groups, file permissions, delegated rights, and access control lists. During migration planning, keep these separate. A sign-in problem is not the same as a permissions problem, and each has different dependencies to validate. Kerberos is the normal authentication path in modern Active Directory. A user signs in once, and the Key Distribution Center, or KDC, on a domain controller verifies the identity and issues a ticket granting ticket, or TGT. That ticket proves the user has already authenticated. When the user needs a file share, application, or other service, the client asks the KDC for a service ticket for that specific resource. The service trusts the ticket, so the password is not sent again. For Kerberos to work reliably, DNS, time synchronization, and SPNs all need to be correct. Here's the Kerberos flow in practice. The workstation contacts the KDC validates the sign-in, and the client receives a TGT. Later, when the user opens a file share or application, the client uses that TGT to request a service-specific ticket. The service checks the ticket, and then authorization determines what the user can actually access. Authentication gets the user recognized. Authorization decides what they can do. NTLM is the fallback authentication path that still appears in many Active Directory environments. It often shows up when Kerberos cannot work cleanly, such as with IP-based access, missing SPNs, or older applications. Unlike Kerberos, NTLM uses challenge response instead of tickets, which creates more opportunity for relay attacks and credential abuse. The goal is not to disable it blindly. First, identify where NTLM is used, why Kerberos is failing, and which applications depend on it. Then you can reduce risk without breaking access for users or services. Before migrating identities, devices, or workloads to Microsoft Entra ID, map what still authenticates against Active Directory. The risky dependencies are often not normal user sign-ins. They are legacy apps, file shares, printers, LDAP binds, NTLM traffic, service accounts, and SPNs tied to Kerberos delegation. If these are missed, an application can fail even when the identity migration appears successful. Use authentication telemetry to see which systems contact domain controllers, then decide whether to modernize, replace, reconfigure, or keep hybrid support for each dependency. Active Directory depends on DNS as its service discovery system. Before a workstation can join a domain, sign in a user, or find directory data, it asks DNS where those services are located. DNS returns records for domain controllers, LDAP, Kerberos, and global catalog servers, and the client connects to the right target. If those records are missing or stale, or if clients use the wrong DNS server, AD can look broken even when domain controllers are healthy. DNS health directly affects identity, access, and application reliability. DNS in Active Directory is more than name resolution. A and AAA records point clients to server IP addresses, while CNAME records provide friendly aliases for hosts or applications. The most important records for AD are SRV records, because they advertise where LDAP, Kerberos, and global catalog services are available. When a workstation joins the domain or a user signs in, it queries these records to find a suitable domain controller. In AD integrated zones, DNS data replicates with Active Directory, helping keep records consistent across domain controllers during operations and migration. When Active Directory suddenly looks broken, start with DNS before blaming authentication. For example, if users move to a new subnet and can't sign in, join devices, or process group policy, the client may be pointing to the wrong resolver or may be unable to find domain controller SRV records. In hybrid environments, split-brain DNS can also send internal names to the wrong place. A simple troubleshooting workflow is to confirm client DNS settings, test name resolution, verify SRV records, and then confirm that domain controllers are registered and healthy. Group policy objects are how traditional Windows environments turn administration into repeatable policy. Instead of touching each machine, admins define settings once and link the GPO to a site, domain, or organizational unit. From there, it can shape security baselines, Windows behavior, user restrictions, logon scripts, drive mappings, and software deployment. The key dependency is that policy processing assumes the device can find and authenticate to Active Directory, usually through correct DNS and domain membership. In cloud migrations, every GPO should be inventoried and mapped to an equivalent management control where possible. Group policy is not only about creating settings, it is also about controlling where those settings apply. Processing starts with local policy, then moves through site, domain, and organizational units, with child OUs normally inheriting from their parents. If inheritance is blocked, upstream GPOs stop there unless a link is enforced. Security filtering narrows scope to specific users or computers that have permission to apply the policy. WMI filtering adds condition-based targeting, such as operating system or hardware attributes. These controls make targeting powerful, but they also make troubleshooting more important. GPO migration is not a lift and shift exercise. Treat every legacy policy as a dependency to validate. Security baselines, password rules, firewall settings, BitLocker, and audit policies may need to be preserved, often through cloud-managed equivalents. Operational items like scripts, drive mappings, printers, browser settings, and registry changes require investigation because they reveal how users actually work. Anything obsolete, duplicated, or conflicting should be retired before migration. This cleanup reduces risk, simplifies Intune or endpoint policy design, and prevents old problems from following you into the new environment. Active Directory migration decisions start with dependency awareness. Kerberos and NTLM shape how identities authenticate. DNS supports domain join, discovery, authentication, and many applications. Group policy centralizes configuration, but it can also hide business-critical assumptions. With these foundations clear, you can judge what moves to Entra ID, what stays hybrid, and what needs redesign before modernization begins.